one thing and that will be lost to time. The one thing that I will slightly narrow the broad context of federated learning here is to say that we're going to talk today, the people that we've brought in for this session. We're going to talk about where each of the data sets that we're thinking about, that we're pulling across the nodes that can run the computation, each have access to what we would consider fairly rectangular data sets with multiple observations. And there is obviously great interest in the federated space, where every individual user who you might measure has their own information on their own device, perhaps in their browser or on mobile or something like that. And we can extrapolate to that, but the 4 people that we brought in today, and because perhaps it's the most obvious direction that OpenDP can assist in, are all interested in settings where there are maybe data sets that aren't large enough to run a computation on its own, or maybe multiple large data sets that we want to learn across in some fashion. Okay, so today we have Michael Shoemate, who you've seen multiple times already and keeps everything running here. So yet again, he's here also in sort of a slightly different role than you've seen him before, as a senior software engineer here in the OpenDP project. He's also been building a federated DP machine learning application for speech recognition. This is a joint use case with Raytheon BBM, and they're interested in differentially private neural networks for these things. And the context there is there are multiple small repositories of data that we want to learn one common model across. We also have Phil Stubbings, who is a staff software engineer in the Privacy Enhancing Technologies group at Data Fleets LiveRamp. He's focused on federated machine learning with privacy aspects. And he was, this summer, we got to work with him as an inaugural OpenDP fellow, working on an application for federated learning. I believe we have Joshua Barron, who's program manager at DARPA in the Information and Innovation Office. Amongst his many people in privacy and security have had the pleasure of working with Joshua. Among this, he is currently running the Cooperative Secure Learning Program, which is a set of seed grants for funding federated learning under different privacy and threat models. And I would like to call out that program is one of the financial supporters of OpenDP this last year. And then joining us shortly in about 10 minutes when his conflict is finished, we're very happy that he agreed. Andrew Trask will be joining us. He's the leader at OpenMind, where they've been working on a number of open source toolkits and applications for federation and for privacy. So to start off with, I'm going to ask the panel respondents to just briefly say what has been their experience in federation. What do they see as for those who have had a connection to the OpenDP project already, how has it worked? How has it not worked for them? What would they need from that? I've got a couple more questions that I'll follow up with, but what I'd really like this to be is more of a discussion so that people who are here and are either interested in the space, want to learn more, or already have systems in mind can air the kinds of things that they want. And then the panelists, perhaps we can brainstorm on ways to make that feasible and kickstart some further work on the OpenDP library in that direction. So let's go Michael, Phil, Joshua, and then Andrew when he joins. Okay. Thank you
all. Great, thanks, James. So I'll start this out by saying I really enjoyed writing automatic differentiators while I was doing my statistics master's at the University of Texas at Dallas, and that kind of informs the direction I went in with the federated learning. My current design for federated learning involves a combination of backprop activation and tensor hooks for PyTorch. It does instance level grad reconstruction, similar to how Pockets does it, but with a twist. And then DP aggregation using the OpenDP library in a way that's compatible with the distributed data parallel module in PyTorch. So I'm kind of leaning on existing capabilities in PyTorch to handle the communication and accomplish DP federated learning. It allows me to privatize gradients before PyTorch distributed synchronizes the gradients among the workers or among the different people who have access to their own data pools. which makes the whole communication layer post-processing. It's currently in a draft pull request on the OpenDP repository. I'm hoping to develop it into a part of the OpenDP Commons. I'm of course open to other approaches and your ideas, comments. Thanks.
I'll go next. Thanks, James and Michael. So a bit more context. I'm part of a startup whose aim has been up until now to create an enterprise-grade federated machine learning platform. So the idea here is to sort of allow a practitioner to seamlessly execute an end-to-end machine learning pipeline on federated data sets, so using familiar tools and frameworks, sort of whilst abstracting away the intricacies of federated learning from the user. We've deployed a number of demos of our platform, initially in the sort of fintech space, and more recently, a sort of more production-grade deployment in healthcare. In terms of applications in fintech, we focused on proof of concepts for anti-money laundering and market manipulation use cases. And in healthcare, we've been supporting a collaboration between HCA and various academic institutions to study COVID data with the aim to better understand patient care practices. In terms of actual federated learning algorithms for horizontal learning, where the same features exist in different locations, we've implemented federated STG and federated averaging. We've tried to couple this with differential privacy during the optimization process so that we can provide stronger privacy guarantees for the models generated. For vertical learning, where there's features existing in different locations, different features existing in different locations, we've implemented a modified form of gradient descent, which uses homomorphic encryption to encrypt the gradients which are passed between the various dataset locations. One of the biggest challenges we've faced up until now is how to allow someone without sort of prior DP knowledge to control the various differential privacy hyperparameters. One thing we've been looking into is taking the trained differentially private models and attacking them with various methods in order to provide the sort of practitioner a set of risk metrics so they can better understand the privacy guarantee attached to the trained models. In terms of our experience so far and what we think about the general direction of the field, we've seen sort of greater interest in vertical federated learning. I think this is because it allows various different organizations to collaborate by combining their features. And I've noticed that at least in the earlier days, there seems to be a small bias towards federated supervised learning. So I'm sort of hopeful there'll be more developments in federated unsupervised learning in the future. Thanks.
Great, thank you both. So the first question I want to ask, which is sort of meta, and it's sort of meant to encompass every possible question that we might be having coming through the stream, and I really would encourage participants to add questions if they have any. Where do you think this OpenDP would like to be future-proof? So where do you think things are going? Not necessarily what is feasible today, but what would be your hopes for a couple of years down the road? And what are the kinds of things that either OpenDP library itself, as a sequence of OpenDP algorithms would have to hold, or what kinds of pieces of common OpenDP common software stack would we need in order to build simple systems that are solutions leveraging the library? Hold on that question, because just before we started, here's Andrew, who I've already introduced. Again, he's the leader of OpenMind, where they've been working on a number of toolkits and applications for federation and for privacy in the open source space. I'd like to give him a few minutes to introduce himself and his own background in federated learning, and then we'll go to our first questions and encourage questions from participants in the chat window, and I'll be monitoring those. Thanks, Andrew, for joining us.
Thank you. Brilliant. Pleasure to meet you, and very honored to be here. Thank you so much for having me. So yeah, my name is Andrew. I lead a community called OpenMind. We're doing quite a bit with federated learning. I would say we're particularly excited about the opportunities that it can lead to science and research. We commonly talk about how this is the gateway to 1,000 times more data in every scientific field, right? When we can study data at another institution with the same ease that we can currently study data sort of at our own institutions, then that's an explosion of information. I would say that we're super excited to be able to work with partners such as OpenDP. We sort of view ourselves a bit more as an integrator in the context of federated learning, in the sense of there are really important problems in the space that where sort of heavy research and heavy algorithms go in to really nice tools such as OpenDP. We sort of consider ourselves very, very lucky to get to build on the shoulders of giants and stitch these together into things, with UIs and cloud deployment scripts and all these sort of nice salt and pepper things that ultimately allow for a good research experience. So yeah, really grateful to be here and super excited about the new code and the new features, and yeah, excited for questions as well.
Great. Okay. So the first question for everybody. Right now, or looking down the road, it's hard to think about predicting the futures. It hasn't happened yet, but where do you think the greatest impacts for federated learning could be? What are the spaces where this is going to have the most payoff for society? What research directions are you interested in? I'll leave it at that. That's for everybody. I'd already given Phil and Michael a moment to think on this question, but feel free.
Okay, well, I'm coming from a much lower perspective, like a technical perspective. I'm thinking availability of primitive functions and libraries like PyTorch for instance level grad reconstruction, or not even reconstruction, just construction. This is something that causes a lot of performance difficulties in the deep learning space for differential privacy, and not just in PyTorch, but also in TensorFlow. And we're seeing a movement and a change in availability of tools for this kind of thing, but it's a long process. So like the VMAP, for example, which is kind of similar to the a primitive in JAX for building these vectorized computations more efficiently.
Bill, Andrew, are there thoughts that you want to add?
Yeah, I can go next. So in terms of impact and public good, like I said, I think that vertical federated learning has got the sort of most promising applications. I mean, for instance, health organizations can collaborate to build better predictive models, and they sit on like a treasure trove of data. And even in government, statistical agencies, for instance, they can build models to create better econometric indicators based on data which is traditionally heavily sort of siloed, and mixing non-traditional data sources with more source-based data. I mean, in terms of sort of things which I think are really exciting in a minute, I mean, as you know, I'm really interested in this area of split learning. I like the method because it incorporates both horizontal and vertical use cases. It's a really sort of flexible method. But recently, my colleague Greg, who's also on the call, he's found a paper from August this year, which seems to expose quite a significant privacy vulnerability in the method by sort of hijacking the learning process. So there seems to be some vulnerability in the learning protocol, which we're currently sort of diving into.
Brilliant. So yeah, I guess building on what was already said, I certainly agree. I think I mentioned in terms of impact areas, it's it's difficult to pick one because I think this theme of if you want to answer a question using data, most people for most problems have a tiny sliver of the amount of information that's actually that exists. relevant to their problem. You know, if you're a cancer researcher at a cancer center, you have a tiny percentage of the world's cancer relevant data. If you are, you know, a quant economist trying to study the economy, you probably have a tiny fraction of the amount of data that's out there describing activity that's going on in the economy. If you're an energy researcher trying to predict where energy is going to be consumed, if you are a trade regulator, if you are like, it's just, pick kind of any problem that people are currently trying to solve with data, and everyone only works with the data at their own organization, that their organization has a copy of. And so, when I think about sort of what these tools are going to allow us to do, I think about the transition from phone books to internet, and if what it did for public data, this is going to do for private data. Like if for phone books, public data was always available. You could call them on the phone and be like, oh, can you tell me what's your business about, and who works there, and all this type of stuff. Can I buy some oranges or whatever, and how much do they cost? And the web really allowed us to make broadly available at scale public information in ways that was not possible before. And I really see federated learning, differential privacy, encrypted computation, these are really coming together to create a new ecosystem where private information becomes just as available. I mean, I think it looks less like individual stacks solving individual problems and more like sort of a new networking protocol, right? Where you pip install a library and you have access to sort of the world's data science information, and you can answer really important questions. And that's 1,000 times more data for every problem if you assume that there's at least 1,000 organizations as big as yours that have data that's similar to it. It's governments being able to collaborate more closely with governments, it's companies being able to collaborate more closely with companies, universities being able to leverage orders of magnitude more information for research. I think it's an incredibly exciting time, and it has only just begun. So if I had to pick two use cases, I'd say breast cancer and money laundering. Money laundering is like the most open and shut problem, where basically there's $1.6 trillion of drug money and human trafficking money and all sorts of stuff that is hidden from regulators just because they play the shell game. They move it amongst a bunch of banks who don't share data with each other. It was like purpose built for pets to solve, right? I mean, it's like basic ledger addition and subtraction. We're not talking like rocket science here, right? Just follow the money. So, some simple SMPC and the right red tape you can cut through, and you can defund or at least very much inconvenience $1.6 trillion worth of horrible activity. It seems like it's worth doing. And the other use case is breast cancer. 1 in 8 women in the world are affected by breast cancer at some point in their life. If you catch it early, most people survive. If you catch it late, most people don't. Catching it early has to do with screening programs. Screening programs are not accurate. Worldwide, it's about a 1 in 4 false positive and false negative rate. Algorithms are even worse. Machine learning is closer to 1 in 3, even for state-of-the-art algorithms in 2001. It's because they're only trained on 1 million images. Something like 8 billion images exist. This is something where we could train a ConvNet that just solves the task and distribute it around the world, and people would have faster, cheaper, more accurate ability to identify breast cancer earlier, and it would save a lot of people's lives. I think it's probably repeatable through a lot of other areas in cancer. Also, a use case like that would really catalyze and help teach the rest of the world that isn't the 60 people on this call, that's what we're here to do, and that's what the potential for these types of tools. So I think the world is our oyster. I think there's no problem that this will not touch. But if I had to pick a couple of use cases, I think money laundering and breast cancer are two of the best.
And just to prove that federated learning is really hard, that is, it's hard to learn things across multiple sources, let alone we now have solved problems that we can now learn across. It's hard to learn across multiple Zoom channels. So we have Josh Barron here. I'd like to introduce him again. He's the program director at DARPA in Information and Innovation Office. And again, amongst the many people here will have met him before in the privacy and security community. Currently, one of his programs is Cooperative Secure Learning, which deals with federation under different privacy and threat models, and is also one of the supporters of financial support backers of OpenDP. So, Joshua, if you want to introduce yourself and any other comments you might have at this moment.
First of all, I'm really embarrassed. I'm so sorry. Something happened on my calendar. It made me miss things.
Joshua's calendar is the most complex object that any of you have ever seen. So
no,
really,
look, there's no excuse. I'm really sorry. I'm really sorry. Okay. So first of all, okay. So let me just talk really briefly about thoughts on federated learning, and then Andrew said a bunch of stuff that I think is extremely interesting, and I think also worth everyone said interesting things, but Andrew, I want to talk a bit more about just the general idea of transitioning privacy preserving technology to real applications, because I think that's worth just talking about, frankly, independently of DP. But in the federated learning space, we are investing as part of the CSL program some money in federated learning, in differential privacy, in homomorphic encryption, and in what is probably fighting words to folks here, but like information theory, non-DP methods that are, that would be, again, like I'm sure, in any event, I'll just throw that out there. The main applications that I'm looking at, or I think some applications I think would be interesting. I don't want to pretend that I have some idea that the magic use cases are going to make the most difference. I don't. Just to throw some others out though, cybersecurity, and especially things like DDoS attacks, like shrew DDoS attacks, the stuff that don't require a ton of bandwidth, but require like would require doing like sophisticated DPI across things that would require leaking. You can't just share that data. There's too much sensitivity associated with it, especially in real time. So I think that there's a there. On top of what Andrew said, I think medical cases writ large is where things are interesting. I guess the tweak that I would put, and again, kind of relates to how I think about transitioning this technology. The question that I would actually start from is, where do there already exist consortiums for information sharing that we can approach to just tack onto them, right? Like, so we shouldn't be doing the hard work of saying, hey, you have this data set, you have this data set, you have this data set, and I will give you DP and now you can all magically work together. But rather talk to folks who have an existing track record. We should be looking to transition technology where there's the least amount of work we have to do. And I don't mean that from like us being lazy. I mean that in terms of the conceptual leap to choose to work together has already been established. And all we're doing is tacking on things that quite frankly, they probably already wanted to do in the first place. And also because they've already thought about doing that collaboration, they'll understand their system well enough to know where a lot of the really important engineering pitfalls are. And so those consortiums exist. I looked whether I could say this one out. We are working with such a consortium in the CSL program. I think I can't say which one, which is really annoying because on a cursory examination of the internet, they have not announced it, so I don't want to kind of say who they're working with. So I apologize for being mysterious. But I think that's one. I guess I would say looking at areas where government data could be helpful to help with, so oftentimes governments do have access to incredible amounts of information for legal purposes. So again, like this is more crazy, but think like IRS or census has like large amounts of data. There are actually really good reasons why they don't cooperate with that data. It's actually, I think actually many people assume that they share that data more broadly than they do, and they really, really don't. But figuring out if there are pockets of government data that is useful that could be brought up in a federated case. Not in a federated case, I was really trying hard to get some variant of differentially privatized, for example, like VA suicide data out there to let people work with it. But it was too much of a lift and it was hard. But that was the thing I spent a bit of time trying to make happen under a previous program that I ran called Brandeis. So I think there's a there. I mean, Jim is certainly welcome to talk about. James Honaker is certainly welcome to talk about like the things that we're funding them to do, because there's an interesting kind of potentially federated case there that could be built in. But again, I don't know if that's been like publicly announced. So again, I just want to be careful. But just stepping back, when we think about transitioning, so I've been working at DARPA for 4 years, working largely in privacy technologies, trying to figure out how to transition them. And again, what I have largely found is doing the least amount of work is the best, which is to say, everyone wants to move towards the case where you have to solve some magic issue where like the data by regulation is not put together. And if only we had differential privacy, we'll put them together. You can do that. Don't let me be a dreamer, try it. Like, don't let me tell you otherwise. I will just say that from what we have found to be more productive is frankly starting at the places where there is no existing regulation, but people just kind of don't feel good about it, and they already work well with each other, and you're just trying to take, as it were, some small epsilon of step to like just push them a little bit further. That is where we have found to be the best things, right? And so it could even be, so for example, on health data, you could even think about, for example, sharing it between like medical departments, right? Or something like that, like starting not at this, sharing across countries or sharing across, people think DARPA and like, oh, we're doing things like, across levels of classification. Like, absolutely not. Like that is a thing that like, there's like actual regulation and law about. And in order to make that happen, I have to satisfy 5 bajillion people. In fact, what I find most, the one that I find most, it's kind of the kind of idol or whatever that I try to go after is actually what the Boston University did with the Boston Women's Workforce work on encryption, where it was like the tech was the least fancy thing possible. It did such a basic thing technically, but like the lift of just figuring out how to actually make it happen and how to get the lawyers on board, that was the really interesting work. And it would be really fascinating to see, like, again, pick the easiest possible technical differential privacy work to do, and then just make that happen and kind of build up from there. That being said, again, if people don't take my thing with a giant rock of salt. If you want to try it with something else, great. We've personally found that enormously difficult to try to achieve. But yeah, I think there's a lot of really interesting space to try to be working here.
There was a question in the chat that Phil directly answered, specific to his question, but it's a broad general question. It was really the second question I was going to have anyway. So I'm going to generalize Pulya's question, which is, outside of the grand vision, outside of the algorithmic research, just in terms of sheer implementation difficulties, like combining differential privacy with multi-node computation and transmission, like what have people found to be the technical implementation challenges, particularly with an eye towards what are the kinds of things that a library is going to have to solve, or that the commons might want to like create some technology for. So Michael and Phil in particular, I'm curious to know, like, what were the hurdles you didn't expect? Andrew, your group, Josh, what you've seen in the programs, what have been the stumbling stones that you were like, I can't believe that was the hard thing to implement. I think that's an interesting knowledge to build here.
Well, I guess I'll start out with saying I can't believe how much computation is necessary for some of these things. There's a significant lift just to train batches of data in some cases, and even the well-packaged, nicely branded libraries out there for doing these things are still slow, and we've definitely made progress towards speeding things up, but that was surprising to me. Working out ways of communication over multiple workers in a secure way is also a pretty difficult problem to solve in itself. I think Andrew Trask has done a lot of work with that, but like specifically in cases where there's many different nodes, instead of like just a client server kind of situation, the number of tools available diminishes quickly as you add more requirements.
For us, one of the main challenges has been messaging infrastructure, which Michael's sort of touched on. When you're thinking about, there's these with federated averaging, for instance, there's lots of serialization and deserialization in place, and sometimes very large models flying all over the network. We find it quite difficult to separate messaging protocols from algorithm, which is why previously when we'd spoken before, I really like PyTorch distributed RPC framework for that reason. It seems to have a nice layer of abstraction, keeping the messaging away from the algorithms. I think that's quite a promising thing to look at. In terms of the API that we sort of offered our sort of front end users, we started thinking about, okay, how do we control for the types of models that practitioners are submitting? For instance, an attacker may, cleverly craft some kind of recurrent model to intentionally memorize data. And there are lots of attack vectors that are really hard to account for. There's always a way for somebody to, you know, sidestep something. It's really hard to sort of cast like a net to catch everything. We're always finding ways to sort of get around the sort of privacy controls. And then, like I sort of spoke about before, this how do we explain what epsilon is to the non-DP practitioner? How can we help them understand this sort of risk and utility trade-off in a way that's sort of optimal to their sort of requirements?
Oh, come on, that can't still be hard, right? Explaining what epsilon is, sorry.
I mean, our idea was, I mean, the main sort of intended user of our platform, at least, was a non-DP practitioner. So the idea is they could just literally copy paste an ML pipeline into a platform and not even understand that it's federated data. Yeah, federation is another thing altogether. I mean, how to sort of communicate these concepts.
Yeah, actually, if I can plus one that, I think it's maybe even a little bit countercultural to sort of the research narrative and where we come from. I think the hardest part that we faced has been like these three ideas, like federation and remote execution, differential privacy and differential privacy budgeting. And like, okay, there's a thing over there and I can study it and I can download some of it, but I eventually run out of this thing called the privacy budget and I can't download anything more, right? And then, you know, secure MPC or encrypted computation or whatever flavor you want that allows me to work with data that's actually at two different locations. Like each one of these things by itself is kind of a mind-blowing concept for someone who's total noob. And the only thing harder than building, building this into software, I think is or doing a software update is doing a flesh and blood update of the 2 million data scientists that exist out there to help get them to understand all this stuff. And so I would say, like, as a heuristic, the thing we've been focusing on, and I think I alluded to this before, but I think that our main role in the network is not doing the the really I think incredible low level hard math and hard problem solving that folks like OpenDP have done, but it's really trying to bridge across and kind of like a product story contribution to the community, where it's like, okay, how can I make it so that it feels like the data is just on my machine and I'm just using NumPy, right? And I never really notice SMPC. I just add together two NumPy arrays that technically were backed by things in two different locations, and it just kind of happened. And like maybe it took a little longer, and I was a little bit like, oh, that was kind of slow. But I didn't have to like know the algorithm. I didn't have to know, oh, there's shareholders, and I'm resharing stuff, and then or I'm bootstrapping my homomorphic encryption or whatever, and it all just kind of goes away. Or with I think or with differential privacy, right? The notion that like I shouldn't have to know what a Laplace or Gaussian mechanism is at the end of the day. Like, I think it's gonna be really hard for us to get around that. But the only thing it seems like we definitely will have to figure out how to get people to understand is I have this thing called privacy budget and I can't spend all of it at once, right? And like, what does it mean to spend it? And what do I do when I need to spend it more efficiently? And that's gonna require training almost no matter what. But it seems like remote execution and SMPC or whatever other encrypted computation backend you want might be hideable, and figuring out how to get all that to work together in like a way that's easy to use is like a real, I actually think that's the most important problem. I think that's ahead of performance because there's a lot of computation that just can't be done right now. And like going from can't be done to it takes me overnight to run a linear regression is actually a pretty big win for a lot of these people, right? But going from like, it's miles of crypto code configuring my SMBC this and my Sigma noise that and all these types of things to sort of train individuals to feel comfortable doing that and to look at their boss and go, yeah, the data is safe. I did it right. I think that might actually be the biggest barrier to wild scale adoption. Lately that we've been saying, like, first we got to make it easy to use, then we got to like yes, get it working, then make it fast, then make it beautiful, was like my old boss used to say. And I think that might be indicative here, where get it working is sort of just replaced with make it so the data scientist doesn't even really know they're doing pets. It just feels like NumPy or PyTorch or whatever else. And same for the data owner, that like, in theory, they should be able to throw their data into a server and it should advertise itself to the network, and they shouldn't have to like bother with it a lot. They shouldn't have to be constantly managing new privacy budgets and requests and queries and all this kind of stuff. Ideally, they can just sort of throw it in there, set a default privacy budget for data scientists and sort of forget it. I think we've got a long way to go before we get there. But when those two things happen, I think that's when we see the big tipping point. And people will complain about performance, and then we'll get a bunch of funding for performance because they'll know that it's really important. Yeah, that might have been a bit long-winded. I apologize.
Yeah, no, but so to build on it though, like if someone, again, most of the tech that I have, I definitely fund work in this very specific space of DP and certainly federated learning. Most of my work has been actually more on the secure multi-party computation or homomorphic encryption side. I guess I would say that pipeline that you just described, like make it work, make it fast. So what I think especially in the kind of novel privacy enhancing technology space, it's, is it possible? Can it do interesting things? And then it's basically a split where historically we've mainly gone is, okay, now that we can do the interesting things, let's do more interesting things and build out what amounts to like a specialist developer, small group of people who can actually do the thing. And then you go and try to sell it, and then you kind of realize that, like, as you point out, like, oh, wait a second, maybe these companies have no earthly idea how to actually implement this, because like it takes an incredible amount of SME knowledge, subject matter expert knowledge in order to do it. One of the programs that I admire that unfortunately got canceled is an IARPA program called Hector. And what it was trying to do, I call it privacy enhancing technologies for muggles. So like literally was the idea of, can you take basic code and compile it into something that's privacy preserving? I think, so that's a really heavy lift for a couple of reasons, one of which I'll get into, but I think in the meantime, you could certainly do APIs that annotate code in real time. Like that's a thing that's doable. I'm pretty sure Joe Neer, who we funded, has done work like that, specifically for differential privacy. I'm sure there are other people in this room who've also looked at similar things. I think that that's somewhat doable, so at least taking some of the risk off of someone with some expertise. One of the challenges you're going to run into, and you kind of alluded to it, Andrew, is that it actually is going to get really freaking hard to define what privacy is, and especially in the differential privacy domain. And so I think that is worth a ton of funding. I had a young faculty award that we announced called Analyzing Differential Privacy Misuse, actually for exactly that reason. I think especially DP is specifically susceptible to people understanding what is and is not kind of secure in that space. And so we actually are funding, this is more or less public because it's basically you just have to track the acknowledgements. Rachel Cummings out of Columbia, together with Alyssa Red Miles and Gabe Kapchuk, to look at specifically user experiences of differential privacy, what they are assessing is secure. But I think, so the two hard parts of what you're kind of proposing about like just letting the stuff be doable is, one, coming up with the right compilers and recognizing that there are certain kind of classical computations that are particularly difficult for pets. You're either going to have to compile around them, or you're going to have to figure out something in that space. And then the other is the kind of common language like the basic understandings of privacy and how that tracks with what the developer, or for that matter, the user is going to experience. And both of those are really, really hard research questions.
Agreed.
Thank you all. Thank you all for all of your comments and for joining us today. Salil, Christine had questions about specific use cases. I don't know if those were I see them as more as pointers, but if either of you want to just make an actual question about a specific use case and drill into anybody here, I'll take the opportunity. Otherwise, Annie, are there any comments that you wanted to make to tell participants for tomorrow's meetings? And let me thank everybody.
Yeah, so you may want to ask Dave Archer of Galois or Rebecca Wright about that. So we did do a bit of that, both in terms of MPC to figure out what the epsilon should be, like in terms of, so basically, can we look at the data to actually figure out the privacy budget and then to do, but then also other issues of using kind of cheating around. So local differential privacy is kind of rough as well, again, that might be fighting words. And, but the point being that like, if you do some of it under MPC, I mean, there are papers on this, right? That you can start getting around that. So yeah, there is work happening in this space that I'm aware of, at least that I funded.
Sorry, I hadn't seen that particular question, but yeah, I think that's a an interesting bet. Christine's raised her hand. Did you want to ask a question, Christine?
Yeah, so I was just going to add the general purpose pointer that so in terms of finding data organizations that are already doing some cooperation, don't have strict regulations, or worry, everything you described, Josh. So within its challenges, that's with the public safety data. And because a lot of public safety is local level government, that's a problem they run into. So Western Fire Chiefs is one great example that Data Lab is already doing kind of exactly what you were describing in terms of sharing data. There's also the Police Foundation, which I think located here in Arlington. There's a few more. So public safety data might be a good place to go look.
As a quick shout out to Christine, so she did some really pioneering work under Brandeis on, and again, I don't know what it needed to be publicized, so I'll just say some real-time occupancy statistics, or kind of real time in order for like public safety purposes. It was really interesting. There's a lot of stuff in like the public safety space where differential privacy can get real interesting, because you really don't want that data released all the time for kind of obvious reasons. But like if extreme events happen, more or less they will overcome the differential privacy issue, like the differential privacy epsilons, and you'll be able to spot them. And so it's almost like this like bumper that, bumper protection that will almost always work, except for when something extraordinary happens and then it doesn't work. Now, you obviously have to think carefully through that. But that was something that Christine worked on for us for some years.
Thank you, everybody, again. Annie, were there things you wanted to say to wrap up today's session?
And I saw Salil unmuted a little bit. Did you want to say something, Salil?
No. I was just going to say my question that Josh answered and Andrew answered in the chat.
Okay. Great, thank you all very much. The panelists, because this is a high point that we're ending our second day of the committee meeting here. So for the audience, if you still have any question or you want to ask us or ask the panelists, feel free to reach out to us. We can be reached anytime, info@opendp.org. And then tomorrow we will continue with the most important, I should say, one of the most important things we're doing, the working groups. And then it is most important that we have your participation. So in the morning, we will have 3 working groups. In the afternoon, we will have 4. I believe you probably have already chosen, 1 in the morning, 1 in the afternoon to participate. And I look forward to seeing you there. And then there will be an email sent out about exactly how to join tomorrow. Watch for the email tonight and tomorrow morning. I believe we will send too. Okay. Thank you so much.
Thank you.
Thanks.